Hello, everyone. Welcome back. Algebra 1 Lesson 4.2. Just want to make sure my sound is good. All right. So we're going to get started today jumping into the lesson. But before we can do that, we do need to go over some rules of exponents. So we're just going to review how to treat exponents. What do you do when you're adding things with exponents or multiplying things with exponents? What does that result in when you simplify them? So that's what we're going to get into today. All right, what is an exponent? That's our first question. What is an exponent? So an exponent is going to be this little number up here. This is called when a letter is written where it kind of floats in the air and it's smaller. This is called a superscript. If you're ever in Microsoft Word or Google Docs or whatever, and you want to write something and you want it to float like that, you would use superscript. So that is the exponent right here. In this case, it's n. And that's what we refer to when we talk about exponents. And what that means is when you have something raised to the power of n, you're going to multiply that thing by itself n number of times. So in this case, a times a times a times a times a times a until you've done it n number of times. Okay, so here's some examples with some real numbers. So we have a base 3 raised to an exponent of 1. Well, that's going to be 3 just one time, so it's just 3. Well, what about if it's 3 raised to the power of 2, or more commonly known as 3 squared? Well, it's going to be 3 times itself twice. So you have 3 times 3. There's the number 3 here twice. 1, 2. And so that equals 9. 3 raised to the power of 3 is 1, 2, 3. 3 times 3 times 3, which happens to be 27. 3 times 4, oh, that's not it. That's what many people do. When I see students make mistakes with exponents, a lot of times they treat this as multiplication instead of multiplying it by itself, multiplying the numbers that you see. So you do have to pay special attention. It's always good, as I say, to use your calculator. When you raise something to a power in a calculator, you're less likely to make a mistake than if you just rush through it and say, oh, well, this is 3 times 4. No, this is 3 raised to the power of 4. So that means we're going to multiply 3 by itself 4 times. 1, 2, 3, 4 times. 3 times 3 times 3 times 3 is 81. That's a lot different than 3 times 4, which is 12. All right, so here are some rules about exponents. Now we're going to get into a little bit more detail about each and every one of these rules, but it's good to have this chart written down in your notebook with the explanations in words, as well as a quick little example written out. So I want you to pause the video and go ahead and make sure you have this in your notes. The first exponent rule is the product rule. So with a product rule, it tells us that when we multiply two bases that are the same, we're going to write the base and add the exponents. Real quick, I've been saying this already, but I want to make sure to clarify that the base is the big number right here that is being raised to the exponent. So this small number or letter is the power or the exponent, and the larger number or letter here is known as the base. Okay, so here we have a base a to the power of n times a base a to the power of m. And the product rule tells us that when we have the same base and they're being multiplied, then we just add the exponent. So that results in n plus m. I wrote a and I added n plus m. So let's do some examples here with some numbers. I have base 2 raised to the power of 3 times base 2 raised to the power of 4. These have the same base, so I'm going to write the base and add the exponents 3 plus 4. So it's going to be 2 to the power of 4, 5, 6, 7 to the power of 7. Here again, the same base, so I'm going to write the base and my exponents are 3 and 8. So when I add those together, I'm going to have x to the power of 8, 9, 10, 11, x to the power of 11. Here I have a base 7. My exponents are 4 and 3. So it's the same thing as 7 to the power of 4, 5, 6, 7. 7 to the power of 7. This one looks a little more difficult. We have two different things with different bases, but we can essentially break this out. And because with multiplication, order isn't really important when it comes to standard multiplication. So this is the same thing as x squared times x to the third times y to the fourth. So in this case, what we're going to do is we're going to write the ones with a similar base, the same base, x. We're going to look at that. And then we're going to look at the exponents, 2 and 3, and add those. So it's 2 plus 3. And then we've got y. And we're going to add the exponents, 1 plus 4. So it's going to result in x to the power of 5 times y to the power of 5 as our final answer. Hopefully you were able to follow along with that. That was the product rule. Now, product is the name of the answer you get when you multiply two things. Quotient is the name of the answer when you divide two things. So now we're going to look at the quotient rule. So when we multiplied, we added. So what do you think we're going to do with the quotient rule when we divide? That's right. We're going to subtract. So here we have 2/5 divided by 2/3. These have the same base. So I'm going to write the base and subtract the exponents. 5 minus 3. So that equals 2 to the power of 2, or 2 squared. Here I have x to the 5th divided by x squared. Now I want to show you with these x's why this subtraction works. It really works well when you have the variables and you have it written in a fractional format. So x to the 5th is really x times x times x times x times one more x. Let's just count these to make sure. 1, 2, 3, 4, 5. There's 5 x's. And on the bottom we have x squared. So that's just x times x. Now you know when you simplify fractions, you can cancel out anything that's in the numerator that matches things in the denominator. So knowing that, we can match up this x with this x. Those cancel out. And it doesn't matter which x you choose. You can choose any x on the top and cancel it out with any x on the bottom. But it's a 1-to-1 match. So we cancel it out. Let's do in blue. This x with this x, and then the green x with x. Now, what does that leave us with? That leaves us with x to the power of 3, because there's 1, 2, 3 x's. And there's nothing on the bottom, so it's over 1. Okay, so let's look at that. If we saw this problem and we didn't want to write it out and do all the crossing out, what could we do? Well, we could just write x, because that's a common base, and then do 5 minus 2, which becomes x to the 3rd power, or x cubed, which is the same thing we got over here. All right, so let's look at r. We have r to the 3rd power and r to the 4th power. These are the same base, so I'm going to write the base, and I'm going to subtract the exponents, 3 minus 4. So this is r to the -1 power. Now we're going to get into negative exponents in a little bit, so put a pause button right there on your mind for that. All right, now let's look at this one. This one is a little more complex, so it might be easier for you to go ahead and draw it out. So we've got x times y times y times y times y times y. And then this one is x and 3 y's. 1, 2, 3. Oop. All right. So I'm going to break out some colored pens here. I'm going to cancel out the one top x with one bottom x. I'm going to cancel out a top y with a bottom y. I'm going to cancel out a second y set, and then a third y set. All right, so what am I left with? On the top, I'm left with x to the power of 1. So that's assumed. We don't need to write it. When there's nothing up there, you assume that's an exponent of 1. And y to the power of 2. And on the bottom, there's nothing but 1. So if we were to put that over 1. So x times y squared. Well, what if we did it the other way? Would we get the same answer? Well, let's look at our x's. We have the same base here. So x, and then I'm going to take the top number and subtract the lower number. So the top number is 2. The lower number doesn't have a number, which means it's an implied 1. So 2 minus 1. Then y is my same base here and here on the right. And I have 5 and 3 for my exponents. So I'm going to do 5 minus 3. Always do the top minus the bottom because order does matter with division, right? And so that's going to leave us with x to the power of 1, because 2 minus 1 is 1, and y to the power of 2, which is the same thing as we got over there. So sometimes when you have things that are a little more complicated, it might be easier to draw it out visually, but you can also revert to just doing it mathematically by doing the function of subtraction. All right, so power rule. So we went over product rule, that was multiplying. We went over quotient rule, that was dividing. So the power rule is when you raise something to a power. So if we have a base A raised to the power x, if we took that and raised it to the power y, that would be the same thing as a to the power of x times y. So when you multiply, you have to add the powers that share a base. But when you have a power that's raised to another power, that's when you multiply the powers. And essentially that works because, for example, here, 2 to the power of 3, 2 times. We'd say 2 times 2 times 2. That's 1 time. Well, we need to do that a second time. So times 2 times 2 times 2, right here, right? So that's a total of 2 to the power of 1, 2, 3, 4, 5, 6. 2 to the power of 6. Now, if we follow our rule up here, we can say that, okay, well, they share a base, so let's write that base. It's a base of 2, and it's going to be raised to the power of 3 times 2, which is 2 to the power of 6. Now, generally, if you were simplifying this, just with all of them, the product rule, the quotient rule, and now the power rule, you would continue to go out and do, okay, well, what is 2 raised to the 6th power? But we just want to see how to follow the rules right now. So we're not actually going to get those answers necessarily every time. So here we have a p raised to the power of 3, which is then raised to the power of 4. So I'm going to write the base and then multiply the exponent. So that's p to the power of 12. Here I have x to the power of m times n, and that's as simplified as I can get this. So xmn, and m comes before n in the alphabet, so that's correct. All right, so z to the power of 5 times 2 is the same thing as z to the power of 10. All right, negative exponents. I told you we'd get there. I'm excited about negative exponents. I like them. What a negative exponent is telling us is that we're going to find the inverse of something. So if you go back to what you know about fractions, if we have a fraction of a over b, to find the inverse of a over b, it would be b over a. So the inverse means to flip it over its fraction bar, right? So the inverse of is. So -1 always implies the inverse. When you see, when you get to linear functions or any function and you want to find the inverse of a function, you're going to see it with -1. When you get up into trigonometry and you want to find the inverse of sine, it can be marked arc sine with a -1. -1 always just indicates the inverse. So what is the inverse of -3? Excuse me, of 3 is what I meant to do. I meant to say just what is the inverse of 3? There you go. What is the inverse of 3? Because this isn't necessarily a fraction. So how do we find the inverse of it? Well, there is a fraction. It's just implied. Remember, the 3 is implied to be over a denominator of 1. So the inverse of 3 is 1/3. So let's look at these. If a factor in the numerator or denominator is moved across the fraction bar, the sign of the exponent is changed. So when we got into this inverse and we said 1/3, the inverse of 1/3 is 3/1, right? Same thing with the inverse of 3. That's 3 raised to the power of 1. But what if we have, say, something x to the -2 power? What does that look like? Well, we're going to still put 1 on the top and x on the bottom. But in this case, because x is raised to the negative power of 2, when we flip it, that 2 is still going to stay there. It's just that the negative goes away because we found the inverse of it. So to simplify an exponent, most of the time you'll have to get rid of all of the negative exponents. And that means you're going to have to write some of your answers in a fractional format. So we need to change it to its reciprocal, and you keep the same number power, but then once you find the reciprocal, you lose the negative. So let's look at this. 2 to the -3rd is going to be the same thing as 1/2 to the 3rd. And I happen to know that 2 to the 3rd is a power of 8. So this is the same thing as 1/8. X to the -5, I'm going to write it out here because I need just a little bit more room. It's the same thing as 1/x to the 5th power. Okay, 4 to the -2 is 1/4 squared, or the same thing as 1/16. And then here we have -4 times x to the 5th times y to the -2. What would we do in this case if we're told we can't have a negative exponent? Okay, will the -4 change at all? No. Will x to the power of 5 change? Nope, that's going to stay right there. The only thing that changes is the y, and normally you see we've been putting 1 on the top, but this y is being multiplied by all these things. So we can put those on the top and put the y on the bottom instead of having to use the 1. And it's to the power of 2. The negative went away when we moved it to the bottom. Okay, so the reason this works is because it's -4x to the 5th over 1 times 1/y squared. And when you multiply fractions, you know that you just carry them all over. So it's -4x to the 5th over y squared. So that's how we get there. But you can, generally speaking, skip this step and just go ahead and write it on the bottom. All right, zero rules. There's 2 parts to the zero rule. So any base, except for 0, raised to the power of 0, or 0 power, is equal to 1. And then 0 raised to any positive term is always going to be 0. I don't have any examples of this, so let me write it. 0 raised to any positive number, 0 to the power of 3. Well, 0 times itself 3 times. 0 times 0 times 0 is 0. So 0 raised to the power of 2,742 is going to be 0. So that's B. It's pretty self-explanatory. Any base except 0 raised to the power of 0 is equal to 1. This is the one that's a little more interesting. Anytime you have the power of 0, you just say simply 1. That's your answer. 6 to the power of 0? Okay, well, that's 1. Y to the power of 0? Well, I don't know what y is. How am I going to find that answer? Oh, it's 1. 7 times a to the power of 3 times b to the power of -1, all that raised to the power of 0, it's 1. This one's easy to do as long as you remember it. So it's always good to have your power rules written down. If you're going ahead and starting your note card that you're going to be using on the test, which is good to go ahead and get started right away on that, you can go ahead and write all of your power rules on there so that you don't forget them. All right, one rules. One rules are kind of similar to the 0 rules in that we have 2 parts to them and they deal with 1s instead of 0s. But any term raised to the power of 1 is that term, no matter what the term is. A raised to the power of 1 is A, right? 5,237,000 to the power of 1 is 5,237,000. All right, so 5 to the power of 1, 5. X to the power of 1, 5. 17,235 to the power of 1 is 17,235. And again, this has an implied power here, exponent of 1. So exponents are always there, just like coefficients. You don't just always see them. Same with like this is over an implied number 1 here. So there's a lot of stuff in math that is implied. All right, 1 to the -3. This gets into our second part of the 1 rule here. 1 raised to any power is always 1. So 1 raised to the power of -3 is 1. 1 raised to the power of 2,742 is 1. Because 1 times itself, times itself, times itself, times itself, it doesn't matter how many times you multiply, it's just going to be 1. Okay? And when you get into the negative exponents, 1 over 1 to the power of 3 is the same thing as 1 times 1, 1 over 1 times 1 times 1, which is 1 over 1, which is 1. So you can see how it always results in 1. Anytime 1 is raised to any power, even 0, the answer is 1. All right, so I've got some practice problems for you. Some of these are more complex than others, but I want you to go ahead and give this a shot. Pause the video, go over all of these, make sure you write them in your notes, and then we'll come back and do them together. All right, welcome back. 3 times 4 to the power of 3, okay? These do not have the same base. So we cannot do anything with the exponents here as far as simplifying the exponents. However, every single one of these are numbers. So we don't have to simplify it. We can just simply find the answer. We can plug it into our calculator. And so when you have your calculator, you're going to do 3 times 4. And then there's a caret button. The caret button is going to look like this on your calculator. So mine happens to be right there, but every calculator has a different. A caret button allows us to enter a power other than just squared, okay? So in my calculator, I'm gonna write 3 times 4, and I think on the calculator it uses an X. 3 times 4 caret 3. And usually when I put in the caret button, 3 times 4 caret 3. All that 3 is going to apply to is what's directly in front of it. So if you wanted to, like down here, when you have something in parentheses with this 3 on it, you have to make sure in your calculator that whole thing is in parentheses, or else the 3 would just be looking at the one thing that is directly in front of it, okay? So you do have to be careful with that caret button. But when I put into my calculator 3 times 4 caret 3, my answer is 192. Okay, now here we have one that's mixed with some variables and some coefficients. And I don't think we covered any of these in our previous practice problems, but hopefully you were able to figure it out. The first thing let's look at is the variable. We have some like bases here being raised to some terms. So if I have a like base, I can just go ahead and write my base. And then since it's being multiplied, I know that I'm going to add my exponents, 3 plus 3. Okay, well, what do I do with my coefficients? I'm just going to do whatever the math tells me to do. And in this case, it tells me to times it. 4 times 2 is 8 times 3 plus 3 is 6. So let me rewrite this. 8 times x to the 6th power. Now, why this works? Well, this is because we don't have to worry about order with multiplication. So this works with multiplication. It doesn't necessarily work with adding because you have to have like terms in order to combine coefficients when you're adding. But with multiplication, what we can do is we can rearrange this. 4 times 2 times x times x times x, that's those x to the 3rd, times x times x times x, that's that other x to the 3rd. So it doesn't matter the order you put it in, and then you can just go ahead and do 4 times 2 to get your 8, and then count up all your x's to get your x to the 6th. All right, continuing on. So we've got x to the power of 5 times x to the power of 3. I'm going to write my base, since I have the same base, and add my exponents, 5 plus 3. So it's the same thing as 5, 6, 7, 8 is x to the 8th power. Here, I want to go ahead and since we're multiplying, I'm going to multiply the coefficient. So 2 times 2 is 4. I'm going to write my like base of x, and since I'm multiplying, I'm going to add my exponents. 3 plus 2 is 5. All right, so now I'm going to get into where we divide. I have the same base of 6. So it's going to be 6, 5 minus 3, because I'm going to subtract my exponents. So 6 to the power of 5 minus 3 is the same thing as 6 to the power of 2, which is 36. You could also have entered this into your calculator. 6 caret 5 divided by 6 caret 3. Okay, and that should give you the right answer. Let's look. 6 caret 5 divided by 6 caret 3. The answer they gave me is 36, so that's correct. Unfortunately, this one got cut off, so we're going to skip number 6, and then it jumps to number 15. So we have x to the 5th, y to the 6th over x to the power of 1 times y squared. So I'm going to write my x's and then subtract my exponents. 5 minus 1 is 4. Then I'm going to write my y, my same base, and then subtract my exponents. 6 minus 2 is 4 as well. All right, let's do the same thing here. I've got x, and then 2 minus 1 is 1, so I don't need to write anything. And y, 5 minus 4 is 1 as well. So my answer is simply xy. Ooh, now this one, we're combining some division and some product powers here. So let's look at these. We're going to have 4 to the power of 3. I want to write this out. Okay, 4 to the power of 3. X to the power of, let's just do 5 times 3 because I can't write all that out. X to the power of 15 and y to the power of 3. You see that this 3, because it's around the parentheses, is going to apply to every single item inside these parentheses, both the top and the bottom, okay? So let me go now to the bottom. We have 20 to the power of 4. So 20 times 20 times 20. And then we have x to the power of 4 and y to the power of 20. 5 times 4 is 20. Now, we are not done because we need to simplify these, okay? So I want to start with some of these numbers here, and I wrote it out like this: 4 times 4 times 4, because I want to show you how we're going to simplify this. 20 is really 4 times 5, 4 times 5, and 4 times 5. So when I write it out like that, I can now go and cancel out some of these 4s because I have a 4 on the top and a 4 on the bottom. Okay, so it's going to end up with my numbers. I'm not going to have any coefficients at the top other than 1, which would be implied. And on the bottom, I have 3 5s being multiplied. Oh, I put it to the power of 3. I combined this with this. So I'm going to rewrite this bottom here in my 4s. I apologize about that. I need to do a better job here paying attention to detail. That is where most mistakes happen. So let's look at this. 4 to the power of 3. Okay, got that. X to the power of 5 times 3. Got that. Y to the power of 3. Got that. All right, 16 to the power of 3. 16 times 16 times 16. X to the power of 3 times x to the power of 3, and y to the power of 4 times 3, y to the power of 12. All right, I'm working on problem 17 here. I conflated 17 and 18 last time. I apologize. All right, so we're going to do the same process, though. I'm going to rewrite my 16 as 4 times 4. I'm going to rewrite each one of these as 4 times 4. And that's going to allow me to cancel out my top with my bottom, okay? 1 on top with 1 on the bottom. It's a 1-to-1 cancellation. So I'm going to end up on the bottom being left with 3 4s being multiplied together. The top, again, I've eliminated all my coefficients. I'm simply left with an implied 1. Okay, so now that I've done that, I can move on and start to write this. I've got an implied number 1 at the top, so I don't need to write that. On the bottom, I've got 4 to the power of 3, which I happen to know 4 to the power of 3 is 64. And I know that because I used my calculator, 4 caret 3. So I'm going to write 64 here on the bottom. So I've done all the numbers. Now I want to look at my variables. My first variable is the variable of x. And I know I'm going to have the same base here. And I've got 15 minus 3. So 15 minus 3 is going to be 12. And that's a positive number. So I want to write it up here on the top, x to the power of 12. Now, when I look at my y's, when I subtract 3 minus 12, I get a negative number, -9. So what I should be doing is writing it on the bottom, but instead of putting a negative, because I wrote it on the bottom, I can drop the negative and just write 9. So my final answer is going to, oops, we're on 17. It's going to be x to the power of 12 over 64y to the power of 9. Now that one was a lot more complicated than the others we've gone over, but when you break it down into bite-sized pieces, it's very manageable, and I hope you were able to get that one correct. All right, so let's look at number 18 here. We're going to go through the same process, but this time to the added exponent of 4 applied to everything in the parentheses. So I'm going to do 5 times 5 times 5 times 5, so 4 5s. And then x to the power of 3 times 4, which is 12. And then y to the power of 1 times 4, which is 4. And all of that is going to be over the power of 20 raised to the power of 4. So 20 times 20 times 20 times 20. And then x is the power of 1 times 4. So x to the 4th. And y is the power of 5 times 4. So 20. So here's where I'm going to break down my 20s into 4 times 5. 4 times 5 and 4 times 5 and one more. 4 times 5. I used up those 20s, so I'm going to cross them out. Now I want to cancel out any 5s I have on the top with 5s that I have on the bottom. 5, 5, 5, 5, 5, 5, 5, 5. And that's going to leave me with 4, 4, 4, 4, 4. So 4 4s across the bottom here. When I enter that into my calculator, 4 caret 4, I get 256. 256. So I'm going to go ahead and start this by writing on my bottom 256. And on the top, my coefficient is going to be 1 because I've canceled out all of my numbers. Now I've got an x here, some common denominator or common bases of x. And I'm going to do 12 minus 4. 12 minus 4 is a positive 8. So I want to put x on the top with a positive 8. Now my y's, I have a common base of y, and then I'm going to subtract the exponents, 4 minus 20. And that gives me a negative 16. So I want to put y on the bottom, and because it's on the bottom, I do not need the negative. I just need the number 16. So this is going to be x to the power of 8 over 256y to the power of 16. All right, whew, done with those. Ready to move on. Now, let's look at these. These are going to be easy, right? We've got x to the power of -1 and x to the power of -8. Well, that's going to be the same thing. Remember, if the item being raised to a power crosses this line, we can get rid of the negative. We see that when we move something like x to the power of -1 down to the bottom, 1 over x, right? Well, it's the same with if you had let's say x to the power of -2, or 1 over x to the power of -2. If you move that to the top, it's just going to be x squared over 1, or simply x squared. So anytime we switch from numerator to denominator, we can drop one of these negative signs. So let's rewrite this without the negatives. So it's going to be x to the power of 8 over x to the power of 1. Now this is a little bit easier for us to manage because we have the same denominator, and we can just do 8 minus 1. So x to the power of 7. All right, so here we have 52 over 13. Let's see, is 52 divisible by 13? It is, it's 4. So we're gonna end up with 4. 52 divided by 13 is 4. And then my exponents are my variables with an exponent. I have a same base of x. And 6 minus -7. 6 minus a -7 is the same thing as 6 plus 7. But using your graphing calculator, you can simply do a minus negative. There are two separate buttons. So you can plug in 6 minus -7 just to make sure you get it correct. And you get a positive 13 there. Okay, so we have a function and we want it the inverse to the power of -3 times a function to the power of 2 times a function to the power of -3. So what is this going to be? Well, they all have a common base of an f, a function. And then since they're all being multiplied, we just add them. -3 plus 2 plus -3. So I'm going to plug that into my calculator. -3 plus 2 plus -3. And I get a -4, f to the -4 power. Hopefully you can see that. That's a 4. -4. All right, so here we have some x's, and again, they're both negative. So I'm just gonna flip it. I'm gonna find the reciprocal. X to the power of 9 over x to the power of 4. Now I can subtract it. I've got x to the power of 9 minus 4 is 5. So x to the 5th power. 24x to the 6 over 12x to the -8. Remember, fraction is just a division sign. So when we divide 24 by 12, 24 divided by 12, we get 2. And so I'm going to start with the number 2 here. Now, my x is a common base for both of these. So I'm going to write my base. And then because it's a division problem, I'm going to subtract them. 6 minus -8. 6 minus -8 is 14. So 2x to the power of 14. I hope you got enough practice that this is now going to be very easy for you, because your next assignment is to just go into your module and complete the rules of exponents practice. So hopefully you will get an A on that and get everything right the first time. Until the next lesson. See you then.